Assalamu alaikum rahmatullah. I hope those are watching these videos right now are doing great and having good health. Welcome to Fahad's tutorial, and this is another very important and basic chemistry class. And you know that previously I uploaded some videos regarding concept of mole, and this video is about the molar solutions. In this video we will talk about molarity, and we will think about that how to find the molarity calculations and how to do some sort of like mathematical problems. And you know that students of English versions, Cadet College and O-Level, this is another important basic of chemistry. And you know there are some mathematics that we need to understand the calculations and how to do it. Let's talk about first the molarity. And this is very important. This is a very common questions on your exam paper, that what is molarity? Before going to explain this, I need to say something that do you remember that what we exactly did before, that when we try to find out the molarity is about the mass of solvent upon the molecular mass. You know about the mole is about the volume upon volume, and you of course know that the mole is also about the number of molecules upon the Avogadro number. And now as we are talking about only the molar solutions, we would only think about these things actually. And these would be the key terms, and these would be the key calculations and key equations to solve the problems about molarity. And there are some keywords that we need to think about it. We need to understand these keywords and the definition of molarity. So think about the definition of molarity is the number of moles. The number of moles. So before, when you started this definition, you must know what is mole. So the number of moles that dissolve in every liter of solutions at a certain temperature. This is a condition. This certain temperature. Okay. So what we need to know first. Suppose there is a beaker and there is solutions. There is a solutions, and in these solutions, suppose there was like sodium chloride. I mean edible salt. Suppose 250 gram, or what is the molecular mass of sodium chloride? Sodium is 23 and chlorine is 35.5. So if we add, we got 58.5. So if what is the definition? The number of moles that dissolves in every liter of solutions. What is the definitions? So suppose this is 1 liter solutions, and here 58.5 gram sodium chloride is dissolved, and then the solution was 1 liter. So what does it mean? That 1 mole sodium chloride, as we know that the molecular mass of sodium chloride is 58.5, so 1 mole sodium chloride is dissolved and it creates 1 liter solution. Now we can say that this solution is 1 molar. So molarity has been expressed by this alphabet capital M, and this is called 1 molar. So if this amount times 2, that amount of gram solution, if it's that, then it was like 2 molar solutions, and previously it was 1 molar solutions. So if the solution is 1 liter, and in these solutions 1 mole of any materials or any compounds which is dissolving in water, that is dissolved, then the molarity of that solution is called 1 molar. If 2 molar is dissolved, then 2 molar. Then if 3 mole is dissolved, then the molarity should say that 3 molar solutions. So we need to understand the molarity first, that the number of moles, So how much? 1 mole is dissolved, 1 molar. 2 mole is dissolved, 2 molar. So the number of moles that dissolves in water I mean in solutions actually, every liter of solutions in certain temperature is called the molarity. And there is another term about molarity. I shall definitely upload these things in a different video, but right now I want to focus only molarity. How to find it out? So if there is sugar, then the 1 mole sugar, that means we need to find out the molecular mass of sugar, and that gram if dissolved in any 1 liter solution, then it's called 1 molar solution of sugar. So here we need to find it out that usually we say it molarity, and that is expressed in molar. So what about these 3 words, decimolar, centimolar and semimolar? This is very common. You must think that when 0.1 mole solute will be dissolved in a solvent, then that is called 0.1 molar, that is decimolar. And when 1 by 100, that means 0.01 molar is the molarity, which is called the centimolar, and in case of semimolar it's called 0.5 molar. So this 3 term is widely used in this academic career. So semimolar, and there are a lot of others actually, but decimolar, centimolar and semimolar is widely used in English version SSC level. So you must know that decimolar is 0.1, centimolar is 0.01 and semimolar is 0.5. Now if I say that a solution of 0.5 molar sodium chloride solutions in 250 ml solutions, if this is the condition, then 0.5 molar sodium chloride is that we know that 58.5 is the molecular mass of sodium chloride. So if I make it 0.5, that means divided by half. So we can say that 58.5 divided by 2 is 29.25 gram. So 29.25 gram sodium chloride is mixed, and then the solution's volume becomes 250 ml. 250 ml. So this is actually the semimolar solution. Okay, so why I'm using sodium chloride? Because the example of edible salt, which is sodium chloride, is very common. So 0.5 semimolar, 0.1 decimolar and 0.01 is centimolar. So when it was used 0.01 molar of sodium chloride, then it will be what? Like we know that 58.5 gram is 1 molar. If it is 0.01, that would be 0.585 gram. That means almost half gram, it's better than, little better than half gram. 0.58 gram sodium chloride is dissolved in a solution. Right now, one thing we need to understand, another 2 keywords, which is solvent and solute. As we are saying since previous times, that suppose this is water and we got like two spoons of sodium chloride here. So 2 tablespoons of sodium chloride is mixed there too. So then what's going on? Like when sodium chloride is mixed and I shake, then after we can't see with our naked eyes that sodium chloride is present because it mixed. Right now you think that when sodium chloride is mixed with water, it becomes a solution, and it's because of there are 2 things. Number 1 is solute and another is solvent. So the solute is the product which is actually soluting in a solutions. Then this solute is actually the sodium chloride, that edible salt, and this solvent which actually dissolves, that is water. So this solute is sodium chloride and water is solvent, and usually we call water as a universal solvent. So the solution is the mixture of solute and solvent. The solute is the elements or the compounds that is dissolving in the liquids, and that liquids is called solvent. So as we are mixing sodium chloride with water, edible salt with water, that water is solvent and this edible salt is solute, and that creates the solution. Hopefully I make you understand that what is the solutions and what is solvent. So these keywords is understandable. Now another two words that we need to remember, that is dilute solutions and concentrated solutions. What is this? Suppose there is a two beaker where same amount of water is mixed. Same amount of water is mixed. Suppose this is 250 ml water is kept and here 250 ml water. If I give 1 spoon of sodium chloride there and I provide 2 spoons sodium chloride here, now I think that the mass of solute is less here and mass of solute comparatively is higher there. So now you see that 1 tablespoon of edible salt is mixed here and 2 tablespoons of edible salt is mixed here. So it would be a dilute solution and it would be a concentrated solution comparatively. But you see, the amount of solute is less here. So that is why there is no standard cutoff mark of being the dilute solutions or the concentrated solutions. But usually if the mass of the solvent is higher, then that solution is called a concentrated solution. And as it is aqueous solution, we usually put like that when sodium chloride is mixed up water, then it creates a sodium chloride aqueous solution. This AQ means this is aqueous. It doesn't mean that sodium chloride is melted. It's about that sodium chloride is mixed with water and creates a solution, and that is why this is an aqueous solution. So usually we understand the dilute solution, which is a less amount of solute in the solution, and concentrated means comparatively higher amount of solute is mixed in the solutions. So I hope you understand these keywords so that we can go further regarding the molarity. So if I'm removing it, so I'm giving you another idea that how to find these molarity solutions, and this is very, very common. And you must know that what I am trying to explain it, this is the main equations of this chapter. Usually when we just find out the mole previously, that we say that mole is the mass upon the molecular mass. It is actually the mole. But right now we need to find out the molarity, and usually it is expressed as S. The molarity of any solution is expressed as S. So S, which is actually the molecular mass, so W upon M, and of course we need to think about that should be in volume, which is expressed at milliliter upon 1000. And these equations will be used further to find out the molarity of any solutions. So as the molarity is the mass of the solvent upon the molecular mass of that solvent times the volume of the equation, volume of the solution in milliliter. This is very, very important. If the volume is given milliliter, then it is okay. But if it is expressed at liter, this 1000 is not required. We need to say like that, W equal to S equals to W times 1000 by MV, or we can say that W equals to SVM by 1000. You can remember by any way, that you can say also that S equals to W into 1000 by MV, or W equals to SVM by 1000. But you must remember this V should be in milliliter. But if this V is in liter, then only W equals to SVM is usable, that this should be in liter. But what we use milliliter, because in the laboratory we need to create some sort of we need to prepare some solutions in milliliter, and then when we'll count the molarity of any solutions, we usually do at milliliter. So that is why when we'll count milliliter, think about that you are in a chemistry lab and you are preparing a solutions and you are doing work with this sort of solutions. Then you feel the good things inside, that this WSVM, it will feel you that a practical test inside. So at first theory and then practical. So W equals to SVM by 1000, and here also. So now from that corner we will use these equations, W equal to SVM by 1000. So that is, so W equal to SVM by 1000 is the equation. But you need to remember what are the meaning of these alphabets. Here W means the mass of the solvent, the mass that will be expressed as gram, and this S is the molarity that will be expressed as M, and this V is the volume of the solutions in milliliter, and this M is the molecular mass. So if I make it a large thing, the W is the mass of the solvent. Mass of the solvent is equal to S means molarity times volume of the solutions in milliliter times the mass is actually the molecular mass times 1000. So this is the equations. So you just remember one thing, that W equal to SVM by 1000. Now one thing, let's do some sort of mathematical problems. Suppose if the question is how much sodium carbonate in a 2 liter 0.1 molar sodium carbonate solution. If this is the question is how much sodium carbonate. So the question is that how much, so I'm writing how much sodium carbonate, is there in a 2 liter 0.1 molar solution. I'm just making it a smaller one or short one so that you can understand this. Suppose this is the question, how much sodium carbonate in 2 liter 0.1 molar solution. Now you think, what is the question? They asked for what? They asked for how much. That means the mass of sodium carbonate. So if I can remember, the mass of sodium carbonate has been expressed by W. So sodium carbonate, as this is given, we need to find out the molecular mass of sodium carbonate, that is 23 times 2 plus carbon is 12, oxygen is 16 times 3. So it would be like 46 plus 12 plus 48. So this is actually 106, and this 106 actually the molecular mass, capital M. 2 liter, that is V in liter, and 0.1 molar is S, because this is the molarity. So now what is the asked data? That they asked for W. So if I think about W, then W equal to SVM by 1000. Now I said to you that earlier that if the volume is given as a liter, then we do not need this 1000. So only I just multiply this S is 0.1 times V is 2 liter times M is 106. So actually this would be 1.06 times 2, so it would be 2.12 gram, I think. Is it okay? 1.06, okay, let's see, 1.06 times 2 is 2.12 gram. That means 2.12 gram sodium carbonate is present. This is very primary level question. So do you understand this? So we are using these equations. We will be using these equations in the following classes also whenever the molarity will be asked in a solutions like this. So this is the first questions. I'm removing it. So I'm also removing it. So you need to think about it, the formula of molecular mass. So whenever the solutions and the solvent is given, you first think about the molecular mass. Again, another question may be asked, like if the question is, okay, what is the molarity of the solution when there is 20 grams, okay, again sodium carbonate, okay, I'm trying to have something new, okay, how will you prepare, the question, how will you prepare 0.2 molar sodium chloride, how will you prepare 0.2 molar sodium chloride solution in a volumetric flask of 250 ml. 250 ml. 250 ml. How will I prepare these solutions? 250 ml, 0.2 molar sodium chloride. Then what is the question has been asked? What I need to find it out from here? So what is given? The given is like 0.2 molar is S. 250 ml is the V in milliliter. Now I find it out the sodium chloride. We just did earlier that the molecular mass is 58.5. So Vm, S and V is given. So I need to find it out W. Because I need to find out that how much gram of sodium chloride I need to prepare this milliliter solution 0.2 molar. So just W equals to SVM by 1000. Okay, and then similarly S is what? 0.2, V is 250, and this would be M is 58.5 by 1000. Now this should be the answer. I mean 0.2 times 250 times 58.5 divided by 1000, which is 2.925 gram sodium chloride will be required to prepare in a volumetric flask of 250 ml 0.2 molar. If the question is how much sodium chloride is required to prepare 250 ml semimolar solution, then it should be 0.5. Suppose in a questions the molarity was not given directly, but they will use this word. Then you need to understand that what is the decimolar, semimolar and centimolar. If centimolar is given, then use 0.01. If semimolar is given, use 0.5, or even decimolar 0.1. So I hope you understand this. But usually what's going on actually, sometimes these easy questions are not available in the question paper. Some tricky questions is also coming. Then I will definitely upload a videos on that. Suppose from the test paper, I'm thinking of it like, suppose there is a beaker is given, or even there is a beaker is given. Here are some solutions are there, and here is also some solutions, and this is written like 250 ml solutions, 5.2 gram sodium hydroxide, 5.2 gram sodium hydroxide. But here 100 ml 0.1 molar sodium carbonate. Now this is also very easy, but when you will understand the concept, suppose two different beaker is given, and here sodium carbonate solution is there and also sodium hydroxide is there, but this is 100 ml, this is 250 ml, this is 0.1 molar. That means molarity of this solution is given, but here how much mass of sodium hydroxide is there is given, but what is not given? Here you think the mass of sodium carbonate was not given, it is asked, and here the molarity was not given, and that is asked. Now you think that in this beaker, suppose this is beaker A and this is B. So in case of A, think about what is asked, W. And we know that W equals to SVM by 1000. And here we know that W equals to SVM by 1000. But S was asked. So as S was asked, so S equal to what? It would be W times 1000 by VM. And frankly speaking, there are some students, they will make some mistakes when S will be in the left hand side. If you don't do it, thank you so very much. But if you will trouble when S will be here, why V and M will be here in denominator? Then I think you should improve the mathematical calculations. This is very, very normal and that is required in case of your level. So W equals to SVM by 1000. So S equals to W into 1000 by VM. Now you think, what's given here? S. You know that S is 0.1 molar is given. V is the volume, which is 100 ml is given. And M is the molecular mass of what? Sodium carbonate. We did it earlier that sodium carbonate is 106. So here would be 106 and will be divided by 1000. So it will be like 10 and it will be like 10.6. So it will be 1.06 gram. And here you see W is what? W means 5.2 gram. So 5.2 is given times 1000 is given. According to the rules, V is 250 ml. So 250, and now M of sodium hydroxide. And what is the molecular mass of sodium hydroxide? If we do that, sodium is 23, hydrogen is 16, and oxygen is 16 and hydrogen 1. So it's altogether 40. So the molecular mass of sodium hydroxide is 40. So here should be 40. So we can do it like 250 by 1004, 4 by 40, 10, and 10 by 5.2 is 0.52. So the molarity of this solution is 0.5 molar. That means when there is S on your left hand side, the answer equation would be molar. But when W, this should be gram. That is very, very important. When you are trying to figure out the mass in the solutions, then answer should be in gram. And when S, that means molarity, answer should be capital M. So you should express this, otherwise teacher may cut down your mark. And I wish that whenever you answer anything properly to your exam paper, that should be errorless. So in my entire video I may have some mistakes, but I think you are capable of to understand the gap, and you people, those who are watching this video, are very, very talented. I hope and I believe it that students of myself, that English versions and O-level, even Cadet college, even any teachers from around the world that are watching this video, I hope that I'm doing it from my best end for academic purpose, that students of English versions and those that are studying chemistry, they can understand well. So this is the calculations, very easy. This is very easy, and this type of figures is common in your test papers. Student of Cadet college and student of SSC level, O level, whenever you watch your chemistry, test paper and previous year's questions, these are common, and you need to think it out that what is asked and how to find it out. So this is about molarity, this is about these equations. You must remember this, that W equal SVM by 1000, and you must know this keyword, what is dilute solution, what is concentrate solution, what is solvent and what is solute, and of course deci, semi, centi. Okay, so this class is ended today right now, and I'm coming up with the next video with percentage of the elements and some mathematical problems in this chapter. So take care, stay well, stay blessed. Bye.